Hi, and welcome to this video on ecological succession. Today, we'll be talking about what it is, the different types, and some examples of each type. Let's get started. Ecological succession is the gradual process by which ecosystems change and develop over time. Let's break this concept down a little bit before we get into it. An ecosystem is a community of living organisms, plants and animals of all different species, interacting with their non-living environment, weather, soil, energy flow, etc. As a community of living and non-living organisms grows and develops, some species may become more abundant, or other species may invade and depopulate or even eliminate other species. Every species has a set of environmental conditions where it will grow and reproduce most optimally and abundantly. As that dominant species grows, it may alter the environment and make it more optimal for another species, in which case the previously dominant species would begin to decline. Let's go over a quick example to help explain this a little better. Let's say you have an area that is composed of just soil. After a year or two, you begin to see some grass and weeds covering the area, growing more lush after a few years. 5 to 15 years after the initial cultivation of an ecosystem, pine seedlings may begin to develop. Pines are sun-loving trees, so they're able to grow quickly in barren soil and with ample sunlight. In many cases, pine will be the dominant species in a growing ecosystem for quite a long time, until they're so populous that their own shade reduces the amount of sunlight they receive. After a few decades of pine dominance and growth, we will begin to see a developing understory of hardwood trees. Hardwoods can grow in lower sunlight conditions that pine cannot. Decades or hundreds of years later, the pines eventually die or are greatly reduced in number and are replaced by the hardwood trees like oak and hickory, which grow optimally in partial shade. In many ecosystems, the oak or hardwood forest is often considered the climax. The climax of an ecosystem basically means it has reached the most stable end product of succession. The oak or hardwood forest will maintain itself for a long ecological time. However, there is no climax of succession when we speak in geologic time, as things are constantly changing. Speaking of change, let's begin to distinguish between the different types of succession. I had mentioned that the oak or hardwood climax forest will maintain itself for a long period of time. This is true as long as it is not subjected to external disruptive forces. Natural disasters or anthropogenic disasters caused by humans may and likely will occur that alter the dynamics of ecological succession or wipe out whole ecosystems altogether. Natural environmental occurrences like forest fires, glacial recession, or volcanic eruptions can decimate large areas and essentially restart ecological succession. Some examples of anthropogenic change that will restart the process could be nuclear explosions, oil spills, or the abandonment of man-made structures, like a paved parking lot. Let's look at a quick example regarding nuclear explosions. The nuclear disaster of Chernobyl left a barren landscape that still, 3 decades later, is uninhabitable for humans. However, radiotrophic fungi have been found growing there, which actually use the radiation itself as an energy source. Gross, but pretty cool. Back to ecological succession. To distinguish between the two types of ecological succession, primary and secondary, we need to take a look at the environment that existed before the drastic change. Primary succession is the formation of a stable ecosystem in a previously uninhabited region. This means no previous soil and no previous living organisms. One really cool example of this is the island of Surtsey off the southern coast of Iceland. This island was formed by a submarine volcanic eruption, reaching the surface in 1963. Since this was a completely new island, scientists were eager to study it and witness firsthand how primary succession takes place. To avoid contaminating the area, few scientists are actually allowed on the island, and it is mainly monitored aerially. Visitors to the island must go through a process to ensure no foreign seeds might accidentally be introduced to the brand new ecosystem. What we've seen so far on Surtsey has been vascular plants in 1965, moss in 1967, lichens on lava in 1970, and the first bush in 1998. By 2008, 61 different species had been identified, 30 of which are currently established on the island. Birds were seen 3 years after the eruption, and 12 species are regularly found there, including a gull colony since 1984 and Atlantic puffins since 2004. So, you might be wondering how vascular plants began to populate the island just a few years after its creation. I mean, there's no soil there, right? It's just a barren, hardened lava rock at this point. Let's talk about pioneer species. Pioneer species are the first species to populate in primary ecological succession. These guys can withstand harsh environmental conditions and carry out nitrogen fixation and inorganic carbon fixation. This means they can take the stuff that's in our atmosphere and convert it into a form of energy they can use to grow, some even without sunlight. Pioneer species like bacteria, fungi, and lichens are able to accelerate the process of weathering. When they die, their organic matter becomes the foundation for a thin layer of soil where eventually grasses and weeds will grow, then shrubs and trees, and finally larger trees and animals. These bacteria and tiny little organisms alter the originally uninhabitable environment and make it more suitable for higher species to grow and develop. Okay, now let's move on to secondary succession. Secondary ecological succession is triggered by an event that deeply disturbs an established ecosystem, often resulting in the disappearance of most above-ground vegetation and living organisms. But the soil remains fertile, with enough organic matter to support the reappearance of life. The main difference between primary succession and secondary succession is the quality of the soil. That is to say, primary succession may be the only succession that happens in an ecosystem. If an ecosystem begins on previously unvegetated terrain and nothing happens that would trigger secondary succession, then the ecosystem will reach a climax with primary succession. Some examples of secondary succession could be a wildfire or logging deforestation. Before we get any further, I want to give you definitions of two classifications of ecological succession. Autogenic succession occurs as a result of habitat changes created by the organisms in the ecosystem, like shading from the development of the tree canopy, which eventually leads to the downfall of pine species. Allogenic succession occurs as a result of changes in the external physical factors, like a tree line that develops because of a colder climate with increasing altitude. In case you have no idea what I'm talking about here, take a second and check out how these trees only grow up to a certain point on this mountain. The colder climate further up the mountain triggers an allogenic succession that prevents trees from growing there. These examples I gave you a minute ago, wildfire and logging deforestation, are also examples of allogenic succession. These external changes in the environment will trigger a secondary succession. And it is known as secondary succession because this land was vegetated before the external force disrupted the ecosystem. Secondary succession will then proceed just as primary succession does, from grasses to shrubs to saplings and then to larger trees, often reaching a climax at the oak or hardwood level. Because the soil left after the destructive force is still fertile and contains ample organic material, the pioneer species don't really need to populate first, and secondary succession continues at a faster rate than primary succession. Okay, now that we've covered primary and secondary ecological succession, let's see what you remember. Number 1, what is one example of a pioneer species? A, grass. B, flowering plants, C, insects, or D, lichens? The correct answer is D, lichens. Grasses, flowering plants, and insects are all examples of higher species that develop in an ecosystem after it is made habitable by pioneer species like lichens. Number 2, what is the main difference between primary and secondary ecological succession? A, the time involved to reach climax status. B, the quality of the soil. C, the number of pioneer species. Or D, secondary succession always occurs after primary succession. The correct answer is B, the quality of the soil. Secondary succession is triggered by an event that eliminates most above-ground vegetation and living organisms, but retains a fertile soil with enough organic material to support the reappearance of life. I hope this review was helpful. Thanks for watching and happy studying.